Hello and welcome to tribetopper.com.
You're watching this video on solve problems in electrostatics from the past papers. So here a question reads 4-point charges capital Q, small q, another capital Q and small q are placed at the corners of a square of side A as shown in the figure. So here we have Q, Q, Q and Q, and the side of the square is A. Find the resultant electric force acting on the charge capital Q. So you can find out that force for any of these two charges. So let's assume we find out the force for this charge Q by all the three other charges. So how can we find out that resultant electric force? So for that we first need to find out the force F1, say due to the charge small q, this one. So we would write down by Coulomb's law, we have it as 1 upon 4 pi epsilon naught times q1 q2. Now one q is capital Q and the other q is small q upon r square. Now the distance between the two is a, so it will be a square. And F2, if we say that is the force acting due to the other small q charge placed here, this one, so it would be the same q upon 4 pi epsilon naught times a square. So these two forces would be same. But now what about the force due to this q? For that we first need to find out this distance between the two charges. So the distance between capital Q and capital Q is the diagonal of the square. So we would just calculate it here on the side using Pythagoras theorem. So a square plus a square, and if we just take the square root of that, that will give us root 2 times a. That's the distance between the charges plus q and plus q placed at the diagonal. Therefore F3, the force on the capital Q due to the other capital Q would be q times q upon 4 pi epsilon naught root 2 times a square. So this time the distance is root 2 times a square. Now we have calculated the three individual forces F1, F2 and F3 acting on capital Q. Now let's see the resultant. How can we find out the resultant? The line of action of this force of this charge is along Q, and this force is going to be here. Therefore we can say that the angle between the forces F1 and F2 is 90 degrees, as we can see here. So we can find out the resultant force of F1 and F2 using the formula F dash, that's going to be equal to, so F dash is going to be equal to square root of F1 square plus F2 square plus 2F1 F2 cos of 90. Now since F1 and F2 are equal, so we can write them as F1 square plus F1 square. So that's 2F1 square plus here also would get 2F1 square into cos 90. Now that is 0. So we have square root 2 times F1 or F2. So we can put the value of any of the two here. So square root 2 times q upon 4 pi epsilon naught a square. Now that is the resultant force of F1 and F2. Now F dash and F3, if we look at it in the diagram, the line of action of forces for both of them is going to be the same, this one, right, along the diagonal. So we just need to add them. Therefore the resultant force R is going to be F dash plus F3, and therefore we just simply add them and substitute the values here. So we would now just take out this q upon 4 pi epsilon naught common, and so we get this expression, and on further just taking the LCM inside the bracket, we reach a final expression q upon 4 pi epsilon naught a square 2a square. So this gives 2 root 2 q